Good afternoon and welcome to this week's episode of the CERIAS Security Symposium from Purdue University. My great honor today to introduce our distinguished speaker, Dr. Dipankar Dasgupta, who is the director of the Center for Information Assurance at the University of Memphis, which is also a NSA DHS Center of Academic Excellence, similar to what we have here at Purdue with CERIAS. So Dr. Dasgupta, welcome to Purdue.
Thank you. Thank you for inviting me to give this talk. Today, I'm going to talk about adaptive multi-factor authentication and cyber identity. So before I talk about this topic, I'd like to give those who are not familiar with my work, my background. I have, let's see. This is my research. I came from AI machine learning and worked on a wide variety of topics using different AI machine learning, and my PhD is in early 90s. Those days, the AI machine learning had a different shape, but over the years, it has not changed. Computational power has increased, and many of these techniques are becoming more popular. And I have more than 300 publications, about 20,000 citations. And these are my published books. So you can see I am coming from, different kinds of AI machine learning. And since 1995, I started applying these methods to cybersecurity problems. So to me, I look at the cybersecurity areas as different problems and how I can solve those using this machine learning techniques. And these are some of my patents and awarded and submitted. So this is the agenda. I'm going to talk about the multi-factor authentication, and most of you already know about it. Then active and continuous authentication. What is the adaptive multi-factor authentication that we proposed, and we probably are one of the first ones we proposed, and what's our strategies. And I'll give 5 minutes demo on the prototype system, and I'll show a use case, 1 minute kind of screenshots of a use case. Then how the whole field of authentication is moving to the identity science, and there are steering committees on identity ecosystem, and there is a FIDO alliance, and they have a FIDO 2 aspects. And recently, you may have heard of zero trust. Everything have to be in zero trust. So how the zero trust is applicable in authentication and identity management. Again, disclaimer, this presentation is a collection of information from different sources, and credits should be given to the original contributors. And my presentation is for educational purpose only. So we all know that identity verification and user identity is very critical, particularly in remote work environment, since without adequate authentication mechanism in place, there is an increased potential of hacking, data breach, and all kinds of bad stuff can happen. There are other aspects also, legal liabilities. So class action lawsuit, individual actions, then reputation exposure, business consequences, and there are different types of breach costs. So you can see the identity verification is the kind of getting the identity credential is the key to the kingdom. If that is stolen, then many things happen in an organization, in a business, and there are many incidents. I'll show you 1 or 2 incidents very recently what is happening, and then we'll go to the specific areas. So authentication is a critical safeguard against illegal access to computing system. So the process of giving individuals access to the system objects based on their identity. And so important thing is that individual who he or she or even the device saying who they are, that should be checked and verified. So correctly identifying the authorized users or the device in an operating environment is a challenge, and that's the problem that we are trying to address. Until now, and even for a long time, user and passwords are being used, and nowadays gradually two-factor authentication is coming into play. And I'll also show that there are a number of vendors who are promoting multi-factor authentication, and that's the topic for today's presentation. So single factor or user password is not secure. Then the second factor is coming, and that second factor can be in a non-obvious way, not through the same channel of communication, the token or OTP, different ways the information is shared. We did some work with MIT a couple of years back, and that tried to address this password-based authentication system, and it was funded by IARPA, and it's called multi-factor authentication. The concept is like this: when someone trying to access to the systems or resources, they will not be directly allowed to access to that. There is a filtering mechanism. The important thing about the filtering mechanism, the way the filtering is done, is a non-obvious way. And that's what I'm going to show you in next slide on. So we have the password profiles, and we represent it in a representative space. So it's assumed that the profile is the green part and the space, rest of the areas are red. Then what we do, we keep these non-password areas in the front layer. So that's why we call it negative authentication. The concept is who you are not. So this is who you, and this part is who you are not. So, and that will go as the security layer 1, and then this is the security layer. And the security layer 2 are kept in a more secure, restricted environment, and every now and then the negative detectors are created and pushed to the front line. So that's was used, and so this is the concept. So if there is any guessing password, they are supposed to be in one of these red areas, and that will be dropped and go for forensic investigation. It will not affect the password management system. That will safeguard the what you call the side channel attacks, or if there is any vulnerability in the password system. And if there is legitimate password is entered or credential is entered, the user will not know that they are being checked by these negative filters, and they will get checked at the second layer, and access to these information sources will be given to them. So that's the basic concept, and it was prototyped, and MIT had some launching of some of the business aspects on this. So what we found out that negative authentication system can detect and filter out most of the invalid requests. But again, it cannot solve all the problems. The offline downloading the things, profile, and finding that may not be able to handle, but the guessing attacks can be defended. And there are similar works has been done on honey words and others in the literature. So again, there is a video, you can find it from this source on that project. So what I was trying to highlight that the concept of authentication is in our core research. Now, then if we look at now, the biometrics become more important, and many of our mobile devices have biometrics. So it provides the uniqueness, right? The authentication through human characteristics, who you are, the physical self. And the question is the collectability. We have to select the features or the characteristics which should be measurable, which it does not have, it does not change that much more frequently. And the universality, ability to use biometric system in a real time at different operating environment. So that's the things that biometrics provide. And there is a study, international biometric groups, and this is a very interesting study. They showed that different kinds of biometrics have different degrees of difficulty. And so in this chart, the further you are away from the center, right, the biometric techniques are much better from the usability perspective. So they have these 4 criteria: intrusiveness, distinctiveness, cost, and efforts. How much effort it will take to get the biometric signature or biometric. And in this stage, so these are the keystroke scan, facial scan, retinal scan, iris scan, voice scan, fingerprint scan, signature scan, and hand scan. So they looked into, so you can see the retinal scan in all these measures are not that good because it is more intrusive. Distinctiveness is good, but it is costly and it takes a lot of effort to take the picture of the retina. Facial recognition goes in a, so in an ideal environment for the biometric, though we have to find it out, which has far from the center. So that's the study, and we use some of the measures in our trustworthy measurement, and I'm going to get to that later. So depending only on the face recognition is not a solution, because as we all know, digitally manipulated face, videos, and image all can can deceive the system and automatic face recognition system based on this face biometric or face recognition. The mask, which was created for movies and other entertainment, are used to disguise the sensory system or cameras to rob banks and any other areas. There are a number of incidents. So, and you can see these are real faces, fake faces can be created with different kinds of gesture, different color changes, and all these things are possible now. Nowadays, there is an app, and many of those are there. Face app is one of those that can change human face to changing gender, changing color, all kinds of things are possible. So, and creating this fake also gone further, which makes this called deep fake misclassification. So the original image can be changed with tiny noise, and in this case, random noise, to have face changes. So, and there are ways to detect, and even your NIST has some competition. Another fake face created by AI looks more like a trustworthy than real faces, but these are all using generative adversarial network again. So the point here is the face recognition cannot be only used as an authentication mechanism or factor. And here is the news where it says that the police testing Amazon's face recognition tool, whether it gives a correct information. And also NIST has a competition where you can see the forensic investigation to automatically detect, locate manipulation of deepfakes. So media forensic competition or challenges, and they have number of examples that people can use to test their system. So what it has been realized that at different environment, the different kinds of authentication modalities have to be selected. In traditionally, if someone uses the wear machine or wireless cellular, the same pattern of connection, in this case example is to the bank, are used. But that same connection or the authentication pattern can be compromised and identity can be theft. In this diagram, it shows that wireless connection, wired connection, tablets, device, and media changes still using the same authentication credibility. So we know there are many modalities are out there apart from what you know, that is the password, PIN, and what the user has, different kinds of information, where the user is, and who the user is. That's a biometric. And multi-factor authentication use two or more of these modalities in current practices. So these are different products in multi-factor in the market. And I put their website links and their capacity on multi-factor. These are duo security. Many of us use the duo security in our university and organization. Okta is another big player in multi-factor authentication. And these are different vendors and how many factors they use and how many factors register. These are all listed here, and their features are and the website. So this is the Microsoft's Azure, where user log in from any device using their existing username and password, and that's how they then create other credential and store in the cloud. And whenever they want to access it, the first factor and the second factor used from the registered one. So what happened recently, you may know that last 6 months news that the number of multi-factor authentication systems are being hacked. And ironically, as far as the report, that a group of teenagers, LAPAS group, it seems they're using different social engineering attacks, and they compromised the multi-factor authentication for Uber, and they also did it for many of the companies' multi-factor authentication systems. So they bypassed, again, many cases, all the details are not available, but it seems most of the cases, they captured the pattern using a social engineering attack and try to compromise that. So two-factor, first factor, they got it. Second factor, they somehow confused the user, and they got that factor information out through a water holding attack or putting a part where the victim put their second factor, and that's how they got the information. And this is you can see this is very recent news, and investigation started in different companies. The this one with the January, the Okta was hacked, and then subsequently other things were reported. So let's see, this is the Okta used by many companies, and those were affected, and that was in January 2022. So question here is that even someone has a multiple factors, that may not be provide enough security. So modality selection should not follow any fixed pattern. So you will have password followed by OTP. So it is, we call it the fixed pattern. Should be unpredictable. That's where the our work comes in. It should be unpredictable. What is coming next, how the user will be authenticated, is not known even to the user. So the process should make consideration of previous selection of authentication factors to avoid repetitive use of the same authentication factor. And that can be done. So far, most of the companies are doing this static multi-factor authentication, though they claim that they are doing, in some cases, some companies, they say we use dynamic multi-factor authentication. Some also claim they use adaptive multi-factor authentication. But how they do the adaptiveness, that's not clear. It is not reported. So here, if you make it adaptive, either static doesn't work, and we have seen still hacking is going. Dynamic has two forms. You can randomly select the authentication factors, but those may not be available for certain device or certain environment. And random also can bring sometimes repetition if you don't have enough possible factors. So adaptive is a calculated way, it's a guided search which can provide better answer with some caveat. And I'm going to talk about those constraints, that how that is possible. So we started, our project was funded by federal agency, and the idea was to greatly enhance the security without changing the user experience. However, when an unauthorized user attempts to gain access to with stolen credential and the additional factors and behavior normally seen does not line up. So we need to watch that as a continuous authentication process. So selection of multiple factors are considered conducted adaptively, considering the operating device and the environment where the user is working, and the way they are connected, and the surrounding conditions. I'll illustrate this, what I mean by this, in this way. So suppose you have 5 factors: face recognition, fingerprint, voice recognition, pass, and SMS. So it's a tiny set, but this illustration will make. Now, if it is a noisy environment, the speaker is on, then voice recognition will not be used. So it keeps track of the environment that we are in before selecting the authenticator. If it is a low illumination area, low light area, then the face recognition will not be used because it may not give the correct answer. So, and similarly, both are noisy and the low light area, then those will not be considered. Now the question that immediately people say, oh, then the hacker will create an environment so that the number of factors will be eliminated, so that you have a reduced number of factors and which can be compromised easily. So it becomes now a pattern, fixed pattern. So to answer that, given a simple scenario. Now, considering today's environment, you have hundreds of different authentication factors. Some are you have to actively involve, some are the passively monitored, and that's how the balance have to be done to address this, breaking the pattern. So in this example, this side, it gives different authentication factors that are available: face recognition, login, CAPTCHA, SMS, fingerprint, voice recognition, keystroke patterns. This is the application domain. We worked on with 30 participants on online course. And on that online courses, we are also the FEMA designated center for developing cybersecurity online courses. So some of the courses we tested with the pilots. So on that environment, so here, I don't know this why this is showing up. So we used the different device, changing different device, changing different media, wireless, cellular, so and the effect of the surrounding. And different modalities are stored in a backend server or multiple server as the system. Our contribution is the selection, adaptive selection of multiple authentication factors. So it's considering the situation, it's selected, face recognition and fingerprinting will be used. So somebody have to put the face and put the thumb for the fingerprint, but both are active authentication in this case. So the whole problem is, I'm going now a little bit on the technical aspects on what kind of machine learning technique we used and how that was considered, the dynamic selection with the guided search. So we have the 4 objectives, and we considered different objectives. This is the trust model. Consider the different factors which will be selected, how much you can trust on certain, and in a wired connection, certain factors are more trustworthy than other factors, and then the selection of factors given the environment, under what environment they are, and then the user experience and the other factors. So we used multi-objective optimization, and those objectives are fed to come up with a solution. So different objectives are fed and considered as a multi-objective optimization problem. Then we used a method called evolutionary computation or genetic algorithm, where it's a population of candidate solutions. In this case, the candidate solutions are what are the possible factors can be used under current situation. Then it will decide, evaluate it, and come up with a subset of solutions. We call it Pareto optimal solution. And those Pareto optimal solutions will select one of them this time, another. So all the solutions are good in making current decision. But the ones which are in the middle, we can choose one of those, but not the same every time. And these Pareto optimal solutions will change with the environment, with the device use, with all other conditions that we talked about. So then we did some stress test, as I said, with 30. So surrounding condition was at different 2-factor based authentication, 3-factor based, and with the data sets, we found that with full light and sound system, voice recognition, and face recognition, here, these are, voice recognition was disabled here, low light environment, both. So the test was done to examine the performance of the system. And there are because it is not a one-time authentication, it is a continuous authentication. So, but in a discrete time. So T1 at the triggering time, what happened that user already decided every 2 hours or every 3 hours I should be authenticated. That's the parameter that user can choose during the registration or at later time. So the time has elapsed. So the now user will be authenticated by password and captcha. Then the device changed. Earlier, the user was using a fixed LAN connection. Now they move to the mobile device. So the device has changed. So then there will be authentication. And assume that the connection is a persistent connection. The user is still connected to their service or the whatever that they are connected to online. But these checks are happening during, this one is media change, wire to wireless. This is a device change. And again, media change. So as the time passes, on different triggering time, this will be, the user will be authenticated. This is a discrete continuous authentication with different triggering events. I'll give you a few minutes demo of how we built it. So then I'll come back to this presentation. Let's see.
Hello everyone. The University of Memphis Center for Information Assurance research team has developed a novel multi-factor authentication prototype. The adaptive multi-factor authentication framework identifies authorized users through an active authentication process using passwords, biometrics, cognitive behaviors, and other factors. Authentication factors are selected adaptively by sensing the user's operating environment. This includes connected devices, communication media, and surrounding conditions. Previously selected authentication factors are also considered. The novel aspect of the invention lies in the design of an algorithm that determines the optimal modalities given the user's operating environment and previously used modalities. The MFA system uses both biometric and non-biometric authentication modalities. Our prototype includes keystroke, voice, face, and fingerprint biometrics, as well as the standard password and passphrase modalities. No biometric data is stored on the client device. In addition to these, out-of-band modalities such as SMS and time-based one-time passwords are supported through the use of mobile devices. The client application captures the ambient light, noise, and location to determine the user's surrounding conditions. The network information is used to determine the type of device being used, fixed or portable, and the connection type, be it Ethernet, Wi-Fi, or cellular. This information is used to differentiate between multiple connections of the same user. All of the information collected is passed to the server over a secure encrypted connection. The server will process the information and return a response directly to the client. If the SMS modality is chosen, the server sends a password to the user's registered mobile device. For the time-based one-time password, a secret is shared with the client during registration. After this point, no communication is required to be made with the phone in order to use one-time password. As a part of user statistics, each connection request is logged in the database. Raw biometric data sent by the user must pass through a feature extraction phase. The relevant features are collected and stored in a template. Only templates, never raw biometric data, are stored in the database. When a client submits an authentication request, the server will execute a selection algorithm that evaluates the user's surrounding conditions and the previously chosen set of modalities to select a new, optimal set of authentication modalities. The selected modalities are returned as a challenge to the user. After the user responds to the authentication challenge, the features are extracted from the responding biometric data. These features are matched against the target features, which are retrieved from the database. Based on the match result, the server will successfully authenticate the user or decline the attempt. This shows the overall system and how the client and server components are connected. Next, we have a demonstration of the software we have prototyped. This is the welcome screen for the adaptive MFA system. To begin, the user is prompted to enter a valid email address. If the email address does not exist in the system, the user is prompted to begin registration. This first page prompts for the personal information of the user. Note that the information on this page is all that most authentication systems require. Because the registration process can be lengthy, our prototype allows the user to partially register their account so they don't have to complete the entire registration in one sitting. Furthermore, this allows the system to be configured to use varying levels of security for different users or user groups. Next, the user must enter their cellular information in order to bind their cellular phone to their account. To confirm the phone number is valid, an SMS message containing a 6-digit code will be sent to the phone. The user then enters and submits the code. To set up the time-based one-time password modality, we use a mobile app to scan the QR code that was generated by the server and contains a shared secret key. The mobile app automatically generates a new code every 30 seconds. The user must enter and submit the displayed code within the 30-second window. For our biometric algorithms, our system uses machine learning techniques to better learn and identify the users. As more samples are given, the more accurate it becomes. Now we begin registering biometric modalities. Here, the keystroke timing information is recorded. You can see these times posted on the screen, but these are not normally visible to the user. Here, a connected webcam captures 10 facial images, which are then sent to the server for feature extraction. On this page, we record the user's voice speaking the phrase multi-factor authentication in order to build an audio biometric profile for the user. For all biometrics, we take several recordings in order to develop a more robust model for the user. Lastly, a fingerprint scanner is used to obtain 3 fingerprint images from the user. This final page is an under-the-hood view of the sensors being read to the screen. Normally, it isn't visible, but it shows the ambient light and sound conditions for this room. These are used in order to adaptively influence the modalities that will be selected during the authentication phase. To gather the surrounding conditions, we use an Arduino Mega microcontroller with light and sound sensors fitted in the customized 3D printed case. To begin authentication, we return to the welcome screen. This time, when the user enters their email address, a selection of modalities are given to be used to authenticate to the system. For the first authentication attempt, face recognition, keystroke analysis, and password were the modalities selected by the system. For the authentication phase, fewer samples are required for extraction than were collected in the registration phase. For the second authentication attempt, the system has selected the fingerprint and passphrase modalities. It is worth noting that multiple algorithms may be used for each modality during a single authentication attempt. In this case, the fingerprint provided is being processed through 2 algorithms for authentication. Coupled with passphrase, this brings us to 3 modalities actually being authenticated, even though only 2 were prompted.
So, that's the basic idea. So, can you hear me?
Yes. Yes.
Okay. So going back to my presentation, so this is how the MFA, adaptive MFA. So you can see it's a continuous identity protection and also always on, ensuring the user identity as long as they are connected to the system or service. It can provide, it's a cloud-based identity management because the server will push to the client how the person have to be authenticated. And it can be federated. It need not have to be in a one server. It can be federated. Different authentication factor can come from different places. So the server, if one server get compromised, the others are still there. The selection algorithm, that's the key factor. That is the just-in-time decision. So most of the, that's what I personally feel, and again, someone can verify. I personally feel most of the multi-factor authentication that are out there, they are not just-in-time decisions. In this case, user, the server will not know how the person will be authenticated at the triggering time. That will be determined by the algorithm based on the consideration, the environment, the device, and the connect. And then the decision will be made and which will be pushed to the client to authenticate. And there we use this machine learning technique, which is a kind of guided search, and which will search the space, and that will determine. So what it is bringing the unpredictability, what is coming next to authentication, that unpredictability it is bringing. And if we have the authentication factors, large number of things, that I'm going to show it. And it has a broad areas of applications. The factors, as you get in new factors for authenticate, you can add into it. So this is the patent which we got in 2018, and this is a company who licensed it, and they are working on different application domain. Particularly, I feel this, it can be deployed at different levels, application level. You can see at the user level, root user, administrative user, guest user. So administrative user will have be more rigorously authenticated than the guest user. And at the document level, we always get the PDF with encryption. But if you see that kind of, with a password protected, or that give your first 5 letters of your name followed by your 4 letters or 4 numbers of social security number or something which is fixed. And anybody who do some social engineering, they will be able to find out date of birth or last 4 digits of the social security number or anything. So that fixed type of authentication is not secure. So we can use factors every time differently for authentication. The system runs in 3 different modes. In a normal mode, if the user, so it is a part of continuous authentication, it will trigger specific authentication factors that are core authentication factors. And it will trigger as changes from wire to wireless, or any media change, or the time threshold is over, or the device change, then it will work. In a vigilant mode, if one of the authentication factor was not been triggered because of the environment is low light area, or there's a noisy environment, then more passive authentications will be considered, and then the triggering time will get shorter. When it goes to the surveillance mode, if it not considered during the selection process, then the space will be enlarged. In other words, a lot of other authentication factors will be considered. And in our version 2, we consider a number of other information from the mobile devices, which was primarily for mobile device authentication using the, and that's the expansion. And now there are more, behavioral and aspects are there, like GPS location, camera, and all gyroscope, walking pattern, and all this can be captured as different modalities for user authentication. Now, let me see, I'll finish with a few other things. There is a nice work, since our work been published, that the adaptation can happen at a different levels. Not only the 3 things we considered, but they followed our work, and they said the authentication and adaptation can happen at a multiple level. In other words, you can see change in technical resources, the reason for self-adaptation. So,
Dr. Dasgupta,
yes.
we have about 5 minutes left.
Okay, so this adaptation can happen at a different level, and these are further expansion of the when to adapt and how to adapt, and that's a good area to look into. Now I'll finish with the slide. There is an identity ecosystem and the areas that now is more important, what we are working on, how this adaptive multi-factor can address the zero trust architecture that is federal government is pushing for zero trust. So it assumes the breach and verify every step on the way, how people access data, whether it is through an application or a device. So regardless of whether the request originated or what resources it accessed, zero trust teaches us never trust, always verify, and that's where the adaptive multi-factor. And you can see there is a consortium called FIDO2. They are using hardware token, that is attestation of the device, and also Amazon SegMaker have similar concepts. So with that, I'll like to stop and ready to answer any question.
Wonderful. We do have a question in the Q&A, and if there are any additional attendees who would like to pose a question, please drop it in the Q&A feature down below. So the question is, with regards to NAS, wouldn't the negative filter be exponentially massive? Suppose you hash a password into an n-bit string. Wouldn't the negative filter have to store 2 to the nth minus 1 values to reject? That sounds quite computationally expensive.
I think the question is a very valid question, and we address this using a deterministic mapping, because we are talking about the space, binary space. And beauty with the representation, you can reduce the, you can use convex or concave, increasing the space or reducing the space. So it is all the mapping function, how you map that binary space to a space. So we used called deterministic metrics. So we use the binary space to a 2-dimensional matrix, and different segments considered as the cluster of points. So our publication, I think it was in 2018 publication, with the entire group worked on that. It's called deterministic negative selection algorithm that was used, which bounded the space, remapping it to a cluster of points. That's a very good question. Yes. But in multi-factor, negative authentication can be one of the factors. Anything else?
Great. Well, with that, we are just over our class time period. I appreciate and thank all of the attendees, and a special thank you to our presenter today, Dr. Gupta. It was a pleasure virtually hosting you here at Purdue University. We hope to see you again soon. Please tune in next week for another live CERIAS Security Seminar, or check out our YouTube and the CERIAS website for past recordings that date all the way back to 1998. With that, have a great week, everybody.
Thank you. Thank you all.